welcome everyone. Today, my topic of discussion is breadth first search and depth first search, known as BFS and DFS. These are fundamental graph traversal algorithms used in computer science to explore nodes in trees and graphs, as they are widely used in applications like robot navigation, network routing, artificial intelligence, and search engines. So, the key difference between them is BFS explores nodes level by level, and DFS explores nodes depth wise before backtracking. Now, I will explain you tree traversal with an example. Here it is shown. So, in breadth first search, we start from the node A, root node A, then we visit all nodes at the same level before moving down. Step by step, first we visit A, then visit B and C, then visit D, E, F, and G. So the traversal becomes like this: A, B, C, D, E, F, G. So BFS explains that or ensures that nodes are visited in order of their distance from the root. This makes it particularly useful when we need to find the shortest path in an unweighted tree or graph. This happens because DFS uses a queue which follows first in, first out, so nodes are processed in the same order they're added. Now, in depth first search, we go as deep as possible before coming back. Step by step, start at A, go to B, then go to D. Since D is a leaf, we backtrack, then visit E, then go to C, F, and G. So here A, B, D, E, C, F, G. So DFS dives deep into the tree before exploring siblings. It is useful for problems requiring full exploration, such as solving puzzles or finding all possible paths. This is because DFS uses a stack or recursion which follows last in, first out. So the most recent node is explored first. Moving towards moving towards second example as breadth first search for graph traversal is start from node A, visit neighbors B and C, visit D, and visit E. Traversal order is A, B, C, D, and E. So in DFS, start at A, move to B, move to D, move to E, backtrack and visit C. So DFS order is A, B, D, E, and C. So DFS traversal can change depending on which neighbor we visit first, but DFS remains consistent level wise. So the data structure used in both BFS and DFS, in BFS queue is used and in DFS stack or recursion is used. As in BFS we use queue because it follows first in and first out. The first node added is the first one to be processed. In DFS we use last in first out stack or recursion, which means that the most recently added node is processed first. So moving towards report path finding. Here grid representation is given. Uh, so here S is equal to start, G is equals to goal, and X is the obstacle. So by using BFS, because for the shortest distance or shortest path, we will use BFS. BFS explore all possible paths level by level, and it also guarantees shortest path in an unweighted grid. So start at S, explore adjacent cells, right, down, left, and up. Avoid obstacles, continue until G is reached. So the shortest path here is S 010212 2, 2, and G. Here it is shown 0, 0, 0, 1, 0, 2, and 2, and 2, 2, and 2, 3. Yes. So here it is we have shown the shortest path. Visual representation is also given. So while using DFS, DFS explores one path fully before trying another. So it may take longer paths, may not find shortest path, requires backtracking. So in conclusion, it is written that BFS is optimal for shortest path, DFS is useful for full exploration. So here are some real world application web crawling in web crawling search engines uses BFS to explore web pages level by level, social networks, maze solving, file system traversal, network routing, puzzle solving, AI gaming solving. So most probably in AI game solving, DFS is commonly used in game trees to explore possible moves deeply. Cycle detection and graphs used in systems like deadlock detection in operating system or network analysis. DFS is preferred here. Broadcasting in networks, message spreading, used when sending message across network. DFS is used. Moving toward implementation of Python code. Here the code is given. You can perform it on your Python Visual Studio and run it. Here the output is given. Now I will explain you the code. Here from collections import DQ. This line is used for imports DQ used for BFS key operations. Moving towards import network gears SNX used to create and manage graphs. Import matplot library.pyplot as PLT used to draw and display the graph visually. Moving towards graph representation, this is an adjacency list representation. Each key is a node, each value is a list of its neighbor. Example as A is connected to PC, B is connected to A, D, E, and so on. Moving toward BFS function, it defines a function for breadth first search. Here, graph takes the graph structure. Start is starting node. Visit is equal to set is start stores visited nodes to avoid repetition or creates an empty set. Q is equals to dq start initialize a queue with the starting node. BFS always starts from the node. Print BFS traversal prints heading for output. Moving towards while queue node is equals to queue dot pop left. While queue loop runs until the queue is empty means all nodes are visited. Node is equals to queue dot pop left removes element from front of queue first in first out. This is why BFS is a level order. If node not is visited, check if node is already visited, prevents infinite loops. Print node, comma, n is equals to. So it prints the node as it prints the node moving towards visited dot add node marks node as visited for neighbor in graph loops through all neighbors of the current node. If neighbors not is in visited not unvisited, add unvisited neighbors to the queue ensures they will be visited later. So DFS function as DFS function defines or uses recursion, visited is equals to none, allows initialization. If visited is none, visited is equals to set. It creates visited set if not already created. Visited dot add start marks current node as visited. Print start and prints the node for neighbor in graph start iterates over neighbors. If neighbor not even visited, DFS graph never visited, recursively called DFS goes deeper into the graphs. This is what makes DFS depth first. Graph drawing function. So graph drawing function here, I have explained the above one. Moving towards graph drawing function. Function to draw the graph. G is equals to nx dot graph creates an empty graph using network X for node and graph for neighbor. This function gives adds edges between nodes, converts its density list visual graph and dot x this line draw graphs with label is equals to show nodes names, node size equals to 100 make nodes larger. So moving towards plt.title adds title to the graph. plt.show displays the graph window. Main execution. Start node is equals to A. It defines the starting node. Graph, draw graph. Graph call functions to display graph visually. BFS graph start node calls BFS function. Print BFS traversal. Moving towards print DFS traversal as it moves to the next line and prints heading. DFS graph start node call DFS function and prints DFS traversal. So the final output is here BFS traversal A B C D E DFS traversal A B D C E. So this programs represent graph using an adjacency list. It performs BFS using a queue where nodes are visited level by level. DFS is implemented using recursion, which explores nodes deeply. Additionally, the graph is using network X and matplot library.